Hello students, welcome to Managerial Statistics lecture on chapter 3 of outcome number 4. In this part, I will be explaining about dispersion, difference between central tendencies and dispersion, range and standard deviation with its merits, demerits along with problems. So, in this outcome, after the end, what students will be able to understand is the topics we are going to focus. So at the end of this chapter, you will be able to understand the meaning of measures of dispersion, differences between central tendencies and dispersions, meaning of range, its merits and demerits, along with simple problems, calculations, meaning of standard deviation, its merits, demerits, along with calculation. So these are the highlights we are going to see with regards to this chapter. Now, focusing on dispersion, with dispersion, we can calculate range. Not only range, we can also interpret, calculate standard deviation, interquartile range, percentile. So these are the various branches which is connected with regards to dispersion. So let us focus on what is measures of dispersion. These are averages of second order. Actually, first order is central tendency. Here, these are the averages of the second order. They are based on the average of deviations of the values obtained from the central tendencies. So that's how we get the average from mean, median, or Z values. So the variability is the basic feature of the values of variables. Such type of variation or dispersion refers to lack of uniformity. So this is what we need to understand with regards to measures of dispersion. So it is the average of second order and average of deviation. Values are based from central tendency like mean, median or Z values. So the variability is the basic feature. Such type of variation dispersion here lacks uniformity. So this is with regards to measures of dispersion. I hope this part is clear for everyone to understand. Now let us move on to understand the difference between central tendency and distribution. There are 6 points to be understood. So let us see with regards to central tendency, that is our mean, median, mode, we calculate with regards to central tendency. That's why I told you before, these are the averages of the first order, whereas dispersion is averages of the second order. And central tendency throw light on formation of the series. Here, it throws light on the formation of series or distribution. And moreover, with regard to central tendency, they do not give detailed features or observation. This is the problem with regards to central tendency. But dispersion give detailed characteristics of observation. So that is why we are using dispersion technique. Now, they do not establish relationships with the item, whereas dispersion establish relationship with individual items also. So that is a difference here. And also the fifth point, if you could see, they do not reveal the entire picture. Here dispersion reveals the entire story. So it is having better than advantage than the central tendency. So it gives only the idea of concentration of item Here in dispersion, it gives idea of deviation from central tendency. So how much from the average it has got deviated, we can very well understand with regards to dispersion. Moreover, considering all these 6 points with regards to central tendency, dispersion is having little better advantage. So that is why we are using dispersion technique. So I hope this information with regards to difference between central tendency and distribution is clear to understand. Now, what is the dissimilarity between distribution? They differ in numerical size or averages in their respective formation. So numerical size variation is there on par when compared with averages when the formation is being made. So this is the first dissimilarity, as we can take the different types of series 1, 2 and 3. Now let us understand what is the difference we understand in this 3 through mean and median are the same. So this is what the series says. Series says three series are constituted differently, though their mean and median are the same. So let us focus and understand the dissimilarity by bringing this same problem. The three series are constituted differently through mean and median are the same. First series is uniformly distributed and there is no dispersion at all. As you can see the different types of series, it is the same problem as I have shown in the previous slide, series 1, 2 and 3. So this shows in the first set of the series, it is uniformly distributed and there is no no dispersion at all. So you can see series number 1. See, everything is 15. Is there any dispersion? No dispersion. Now, if you look at the second, it is having some sort of dispersion. See, it is 11, 12, 13. So, what is that dispersion? So, that is in second series, we are going to identify from the central tendency, and here uniformity is distributed. So in the third series, it shows a high degree of dispersion and there is uniformity among dispersion. As you can see, 3, it's not very close here, 3, 6, 9. So there is some difference. So that is why third point, it shows a high degree of dispersion and there is uniformity among the items. So in conclusion, by looking into series 1, series 2, series 3, what we can say here, the larger the dispersion is, the lower will be uniformity. So you can understand, larger the dispersion is, series 3, it is very larger when compared with the other two. So in the end, we can say the larger the dispersion is, lower will be uniformity. It should be very close. Then only uniformity is even. So this is the point we can understand with regards to dissimilarity between distributions. So I hope this series of information with regards to the table values among different types of series are easy to understand and also to write the inference to conclude if the dispersion is lower, that is for example, larger the dispersion is, lower will be the uniformity. So lower the dispersion, larger will be the uniformity, opposite. This is what we need to understand. So I hope this information is clear. Now let us see what are the objectives of calculating the average of the second order. Second order is nothing but our dispersion, right? So why we do, what is the objective? The main objective is to ascertain suitability of the first order average. So the first order average, which is being calculated from the mean, median and z values, are suitable or not. So that is why we are calculating. Second one, to decide the consistency of performance and to reveal the degree of uniformity in the series. How consistent it is. The consistency is very close or very far. So that we can understand. That is the second objective. Not only that, what is a uniformity? Whether they are very close in variation or very far, uniformity is there or not in the series, that we can understand very well. So these are the information with regards to dispersion. I hope this information is clear to understand. So in the previous slide, I had explained about dispersion, differences between dispersion and dissimilarities and objectives. These are the topics I had discussed with regards to the previous slides. Now, in this part, I am going to explain about the properties of good dispersion. Not only that, measures, range and its merits and demerits, and also how to calculate range and its coefficient of range. So let us see one by one. First, let us focus on the properties of good dispersion. How it should be, what are the properties? The first property, it should be simple to compute. So it should be very simple so that further calculation, whatever it is possible. The second property should be easy to understand. If it is complicated, then it will be difficult. So it should be easy to understand. The third, it should be uniquely defined. Specifically, uniquely, it should be defined so that there won't be any distractions. And also, it should be based on all observation. Should not leave anything. You should take all observation without unduly being affected by extreme observations. So all must be taken into account without unduly being affected by extreme observations. So this is the fourth property. The fifth property, it should be capable of further algebraic treatment. So if you made it in a systematic logical way, it will automatically enable for further algebraic or mathematical treatment. So these are the properties of good dispersion. So I hope these points are clear to understand to chart out what are the properties of good dispersion. Now, let us move on to the next part to understand measures of dispersion. What is measures of dispersion? The term dispersion, variation or deviation is studied with reference to two measures. So in this, we need to understand it is having two. One, it is called absolute. The another one is said to be relative. In absolute, we are going to look upon measures of dispersion expressed in the same unit in which data of series is given. So this is the point to be noted with regards to absolute dispersion. In relative, measures of dispersion are expressed in percentage or ratio. So that is the difference between absolute and relative. And moreover, it is also called coefficient of dispersion. So which one is absolute, which one is relative? It is very clear. Here it is expressed in same unit in the data of series, right? Whereas in relative, it is expressed in percentage or ratio. And also it is moreover called coefficient of dispersion. So I hope measures of dispersion, how it is being segregated, what are all the points connected with absolute and relative is clear to understand. So let us move on to the next part to understand relative measures of dispersion. What is this relative measure? I told already it is expressed in ratio or percentage, and they are very much suitable for comparative study. To compare, if you make the ratios, it is very well. For example, 2 years or 3 years, you take the same ratios with regards to dispersion comparison. will be highly useful to make decisions. So you can see here how they are making this technique with regards to relative measure. First, range is being calculated. And from the range, what is the standard deviation? And from the standard deviation, what is the variance? So these are the techniques connected and calculated with regards to relative measures of dispersion. So let us see one by one with problems and examples. Now, what is range? First we need to understand. Here, range is the difference between largest and smallest value. So, whatever series of data is given, you need to identify which is the highest value and which is the lowest value. So, difference between these two, we will get range. So, values in between the two extremes are not at all taken into consideration. So range gives an extremely simple indicator of the variability of a set of observations. So it is denoted symbolically as R. R is equal to highest minus smallest. This is the formula for calculating range. What you need to do is very simple. Whatever number, whatever series of data is given, take the highest value, take the smallest value, find the difference. So this difference is what we call here range. So I hope this example is clear. Now what are the merits and demerits of range? We need to very clearly understand. What is the merits? Let us see first what are the merits. First merit, it is simplest measure of dispersion. It's very simple. It is rigidly defined, easiest measure of dispersion to calculate. See, as I told you, how to find range, take the highest value, reduce the lowest value, you get the range. So it's very rigidly defined, easiest measure of dispersion to compute. It is readily comprehensible and it requires very little technique. No major techniques are required. And it is very comprehensible, very short, very brief. So it is also useful in statistical methods of quality control. Mainly they are using this technique in quality control. And also it is useful in studying variations in the prices of share and stock. So in Muscat Securities Exchange, they are using to study the variation. Whether the variation is more or less, what is the gap with regards to using range, it can be identified very easily with regards to the prices of shares and stock which is being traded in Muscat Securities Exchange. And also it is useful in studying weather condition. Weather forecast also it is possible by studying with regards to range and dispersion techniques. Now what are the problem? Let us see problem number 1. It is not a suitable measure of dispersion as it is affected by extreme value. So it is definitely affected by extreme values. So it is not at all suitable. Again, it is not suitable where the class intervals are open in the distribution. So again, when the class intervals become open, it's not suitable for distribution. Third one, it is completely depending upon two extreme values and not on the other value. So completely it depends only on the two extreme value. So that is how it states the relation. And also it is, since it is completely dependent on two extreme value, not on other value, again it becomes a problem. So it is not suitable for mathematical treatment. It is very sensitive to the fluctuations in the same size. If the size is same, it is very sensitive, keeps on changing. So more fluctuations will occur by using range. So these are the merits and demerits of range. So let us see how to calculate range. What is the formula? Range is equal to largest value minus smallest value. So large is represented as L, smallest is represented as S. This is what we call an absolute measure. Now, when we use coefficient of range, that is, we need to take largest minus smallest divided by largest plus smallest. So this is what it is represented in the formula, and this is a relative measure. Range is absolute measure, coefficient of range is relative measure. Now you can identify the difference between absolute measure and relative measure, and also you know the formula for range and coefficient of range. So I hope this information with regards to calculating range formula as well as calculating coefficient of range is clear to understand. Now let us look upon calculation of range and coefficient of range with a simple problem. So from the values given, we need to calculate range and coefficient of range, right? So how to calculate? Let us apply the formula. I am taking the same problem. Now what we need to do? How to calculate range? Range has a formula. R is equal to L minus S. So we need to calculate separately for series 1, series 2, series 3. Okay. So series 1, if we calculate, so you can identify the largest value in series number 1 is 17 and the smallest value is 13. So 17 minus 13, series 1 range will be 4. So I hope series 1 is clear. Same way if we do for series 2, largest value if you identify it is 21, smallest is 9. When you find the difference, range will be 12. Same way for series 3, largest is 29, smallest is 1. Range will be 28. So this is an absolute measure. So I hope you know how to calculate range. By using this formula, series wise we need to calculate like this. So step number 1, I hope it is clear to understand. Now we need to understand how to calculate coefficient of range. Already we know the formula for range, right? Coefficient means L minus S divided by L plus S. That's all. So this is what you have to keep it in mind. So series 1, already we know 17 minus 13 divided by 17 plus 13. So you will be getting coefficient of range 0.1333. Same way for series 2, 0.4. Same way if we calculate series 3, we will get 0.9333. So now we know how to calculate range and coefficient of range. Whereas range is absolute measure and coefficient of range is what measure, dear students? Relative measure. So this is what we need to understand. This is the formula. You have to keep it in mind for calculation of range and coefficient of range. So I hope this example is clear to understand. And finally, by comparing all these three, you can see here series 1 is less dispersed and more uniform, while series 3 is more dispersed but less uniform. This is the conclusion you need to write by comparing all the three, right? So series 1 is more uniform. Y means 0.1. Series 2 is 0.4, 0.4 and 0.9. So series 3 has more variation. That is why we are writing it is less uniform. Series 1 is more uniform. So I hope this conclusion with regards to calculation of this problem is very clear to understand. So once again in the previous part I had explained about properties of good distribution, measures, range, its merits and demerits, and also I had taught some calculation of range and coefficient of range with simple problems. Again in this part, I will be discussing about range and its coefficient with two more problems with solutions, as well as I will also be focusing on what is mid-range, what is the meaning of standard deviation, its properties and merits. So this is the part we are going to see with regards to this session. So let us move in to understand further problem number 2 with regards to calculation of range and coefficient of range. It is the same problem as we have seen in the previous slides. Now we need to calculate range. You know very well, range has a formula. What is the formula of range? Here, first we need to use formula range is equal to L minus S. Same way for series A. Previous problem series 1, 2 and 3. Here series ABC is given. You can identify in series A which is the largest value 14, which is the smallest value 10. So 14 minus 10, the first range for series 1 will be 4. So series 2, again it will be 4 because largest is 44, smallest is 40, as you can look down the problem. Series 3, if we calculate, largest value is 104 and smallest value is 100. So the difference is 4. As you can see in all the series, the range looks same. So series 1, series 2, series 3, in all the calculation, the answer is becoming the same. So let us calculate step number 2 with regards to coefficient of range. So what we need to do, we know how the formula to calculate range, L minus S. Here for coefficient, L minus S divided by L plus S. So if you apply and calculate, the first series coefficient of range will be 0.1667. So same way, similarly, if you calculate series 2, 0.0476, and series 3, it will be 0.0196. So I have given the steps. Even if you note down these steps, and you can, if you calculate in your calculator and try to check whether the answers are right, right? So it is suggested that, dear students, don't just only watch, you have to watch at the same time, take your notebooks, right, your calculator, everything ready with you. Look at the problem and you yourself can solve as the steps I have shown in this part of the PowerPoint. So I hope how to calculate coefficient of range is very clear for everyone. Now we need to write the conclusion. As you can see by comparing all the three series, series C is less dispersed. See, it is 0.0196, right? So series C is less dispersed, more uniform. Series A, you see, it is more dispersed but less uniform. This is the comment finally in your own understanding you can write. There are no hard and fast rules, just compare, right? After comparing which is the least one, we need to write it is less dispersed, more uniform. Which is having more result, we have to write more dispersed, less uniform. So that is the way we need to understand and write conclusion after calculating range and coefficient of range for this type of problem. So I hope this example is clear to understand. Let us see one more problem with regards to range and coefficient of range. It is the same, but here x and frequency, only two values are given. So let us see how to calculate range and coefficient of range of the series and state. Which one is more dispersed and which one is more uniform. So let us see. The same formula we need to use for range. So this is the problem you look below. Now you have to use for x and frequency. Now L minus S, if you see 42 and 6 is the smallest number. So the first range calculation for variable x is 36. Now we need to calculate coefficient of range. How to calculate? We know L minus S. So L plus S, if you apply, you will get coefficient of range. So in this regard, after calculating, you will get the result 0.75. So in finding the range, the frequencies are never taken into account. This is the point to be noted, dear students. That is why I have brought this problem. It is very, very important. It is a tricky problem, challenging problem. We will be giving you X and frequency. Frequency is just to confuse you. So in finding the range, frequencies are never taken. That is why we are bringing this problem for your better understanding. So you should take only the variables concerned. Frequency should be ignored. So I hope this problem is clear for everyone to understand. Now let me explain what is the meaning of mid-range. So mid-range or mid-extreme of set of statistical data value is the arithmetic mean of the maximum and minimum values in the data set. So mid-range is a midpoint of the range. So very clear midpoint of the range. Such it is a measure of central tendency. So as we know mean, median, we take all data either arranged or not arranged, it determines the midpoint. So when it determines the mid-range is the midpoint of range, we call mid-range. Not only that, mid-range is rarely used in practical statistical analysis as it lacks efficiency. Maximum, if you look upon the study, it is not more widely used, it is very rarely used as an estimator for most distribution of interest because it ignores all intermediate points and lacks robustness. That is why it is very rarely used, not widely used. And also it is simple to understand and calculate. So what is the formula for calculating mid-range? Highest value plus lowest value divided by 2. This is the point you have to keep it in mind. So I hope this example information with regard to mid-range is clear. Mid-range is nothing but midpoint of the range, right? And it is not widely used, rarely used. And how to calculate, what is the formula? Highest value plus lowest value divided by 2. So these are the major highlighted points you have to keep it in mind. So I hope this information is clear. Now let us understand what is the meaning of standard deviation. So standard deviation is a measure of dispersion of a set of data from mean. So from the average, how far the deviation, whether it is closer or far, to understand we are calculating standard deviation. So it is a measure, so it is the absolute variability of a distribution. The higher the dispersion or variability, the greater is the standard deviation, and greater will be magnitude of deviation of the value from the mean. So this is the point to be kept in mind. Higher the dispersion or variability, greater is the standard deviation will be greater, and greater will be magnitude of deviation. So it is depending on the study we need to understand whether the deviation, standard deviation it is showing more, whether it is good or not. It depends upon the study the researcher is doing. And this standard deviation was proposed by Carl Pearson in the year 1983 and it is denoted by sigma. You can see the standard deviation symbol. So this is how it is represented. Now let us focus next on the properties of standard deviation. So what are the properties? It is only used to measure spread or dispersion around the mean of the data set, right? When we are using, we will be using this standard deviation to measure the spread. How is the spread? So by taking the mean of data set, we are calculating the standard deviation. So this is the point we have to keep it in mind. Standard deviation is never negative. This also we have to very clearly keep it in mind, as well as it is sensitive to outliers. So for the data with approximately the same mean, the greater the spread, the greater the standard deviation. So these are the properties of standard deviation we need to understand. So when are we using actually to spread or dispersion? By using the mean data set, we are using standard deviation, and the calculated results will not be negative. And also, moreover, it is very sensitive to outliers, and approximately same mean. If the mean is same, greater the spread, greater the standard deviation. Standard deviation will be more. So these are the properties of standard deviation we need to understand. So I hope this is clear. Now let us understand what are the merits of standard deviation. What are the advantages? So if you do standard deviation, what are the benefits? The first, it is rigidly defined, easy to compute and understand. Anybody can understand very clearly. So it takes all items into consideration, gives weight to deviation. What is a deviation? Depending on the series of data to their size, it gives the deviation. The third is it is less affected by extreme values of variable, not greatly affected, only less affected. And also it removes all the irregularities by obtaining deviations and provides a correct measure. So if you calculate the mean exactly correctly, so what is the level of deviation and irregularity, it will clearly focus and it will clearly express. So these are all the merits to understand standard deviation. So I hope these points are clear to understand. So in the previous slides, I had explained two problems connected with regards to range and its coefficient of range, as well as mid-range, standard deviation properties and merits. Now, in this part of the discussion, I'm going to explain about the demerits as well as how to calculate standard deviation steps with problems. So let us focus. Now let us understand what are the demerits of standard deviation. What are the problems? The problem number one here, it does not lend itself readily to algebraic treatment. So it is not by default readily lending itself. Further better accurate calculation only it will lend, but here by default it does not lend itself for algebraic treatment. This is the first problem. Moreover, it ignores the negative deviation and treats them as positive, which is not justified mathematically. As you know, the results are only positive. Even the negative also it is assuming as positive. So it is not justifiable. This is the second problem. Moreover, third problem, it is not a satisfactory measure when deviations are taken from mode. So if you taken from mode, here it is not satisfactory measure. If it is mean, it is fine. So if you take from mode, it is not satisfactory measure. So this is the third problem with regards to standard deviation. The fourth problem here, it is rarely used in social sciences. Standard deviation nowadays, if you see, it is very rarely used. But here in the case of calculating student marks, here, for example, I don't know whether you know or not, teachers, they know very well they are using the standard deviation to find how the deviation occurs by taking the mean. Here also mean is being taken, mode is not being taken. If you take mode, again it becomes not a satisfactory measure. So this is what we need to understand. Also, it is not suitable when the class intervals are open-ended. Only in the case of closed-ended, it has advantages, but in open-ended, again it is not suitable. So these are the demerits of standard deviation. Let us understand how to calculate standard deviation. It is very simple with regards to individual observation. Standard deviation, as you can see, the symbol is equal to square root of sigma d square divided by n, right? Or we also have another formula, that is sigma x minus x dash whole square divided by n. So this formula is an example for absolute measure. And for relative measure, what you need to do, standard deviation divided by mean into 100. This is what you need to determine for coefficient of variation. So I hope this example is clear to understand with regards to demerits as well as how to calculate standard deviation. Now, what are the steps to be followed while calculating standard deviation? You need to calculate mean. So you need to note deviations to be taken from x minus x dash. We call x minus x dash or d. D is nothing but deviation. Okay. So d here it is noted as deviation. How it is calculated? X minus x bar. X bar is nothing but the mean. So square the deviation. So if you square the deviation or d square. So this is step number 3. The next step, you need to multiply d square by the frequency f. So total the fd square column, we will get sigma d square. So divide sigma d square by n and obtain the square root of sigma d square by n. So this is the steps to be followed while calculating standard deviation. Now let us focus on a problem. Following are the runs scored by two batsmen A and B. So this is the runs given. So you need to calculate standard deviation. So how to calculate? Let us see step one by one. So step 1, what you need to do, you need to make a table like this. Clear? So you need to differentiate batsman A, batsman B. So batsman A, what are all data given in the question, you need to copy down like that, as well as batsman B, you need to copy down. Then you need to write x minus x dash, then x minus x dash square. Either you can put d or d square in both the cases of batsman A and batsman B. How to calculate mean? Now I will tell you. The step number 1, we need to make the total of batsman A, that is called x. Okay, when you make the total, it is said to be sigma x. So if you take your calculator and make the total, you will get the total 330. This is your sigma x. The next step we need to calculate mean, that is deviation x dash. How to calculate x dash? We need to take the formula x dash is equal to, as you can see below, sigma x by n. So sigma x is 330 and number of count is 5. So n is number of count. So if you divide 330 by 5, you will get 66. That is what I have written here in this second table, 66. This will not be given, dear students. This is to understand how to make the deviation, that is your x dash. That is the example you can see below. I brought it in this for your understanding. Now what we need to do, this is x. Can you see? All this value 70 to 40 is x. And x dash is your 66. Please remember, okay? Now 70 minus 66, 4. 90 minus 66, 24. 80 minus 66, 14. 50 minus 66, minus 16. 40 minus 66, minus 26. This is what you need to understand. Okay. Now, when you make this total, sigma d is 0. You can check the total. You can add the positive value and you can reduce the negative value here. Sigma d is 0. The next step, what you should do, you should square. So whatever value here, you can see 4. So 4 into 4, 16. 24 into 24, 576. 14 into 14, 196. Minus 16 into minus 16, positive 256. Please be careful. You need to be very careful. Don't put it in negative. Minus into minus is plus. So I hope that you know simple calculation. In that regard, I am continuing. So 26 minus 26 into minus 26, 676. So if you make the total, we call here sigma d square, 1720. So we made this for batsman A. The same way we need to continue for batsman B. First we need to make the total. This total is sigma x. As you can see here, 300. So 300 divided by 5, we need to calculate the x dash. So we will get 60. As you can see, this is what I have written in D60. This will not be given in the problem, dear. You have to calculate. Please remember, dear student, this 60 for your understanding how to calculate, I brought this here. Okay. After making the total, you need to calculate mean, then bring this 60 here. Then it is very simple. These are all values of x minus x dash. X dash is same for all. Okay. So 70 minus 60, 10. 90 minus 60, 30. 50 minus 60, how much? Can you guess, dear students? Minus 10, yes. 60 minus 60, 0. 30 minus 60, minus 30. So if you calculate sigma d, again 0. Next we need to square. 10 into 10, 100. 30 into 30, 900. Minus 10 into minus 10, positive 100. 0 into 0 is 0. Minus 30 into minus 30 is 900. So if you make the total, this is your sigma d square total 2000. So I hope the solution to calculate for batsman A and batsman B is clear up to this level. Still the problem is not over. I hope this is clear. Now let us calculate with the available results to proceed for standard deviation. So for batsman A, so we calculated the mean, we know it is 66. And we need to calculate standard deviation, sigma d square by n. So sigma d square we know 1720 divided by 5. Then if we calculate the square root, the value of standard deviation will be 18.547. Same way, what we need to do, we need to calculate coefficient of variation. So coefficient of variation is standard deviation divided by mean. See, here we have the standard deviation, mean is 66. Okay, so if you multiply by 100, it is 28.1%. So we did it for batsman A. Same way we need to calculate for batsman B. So we already know the mean value is 60, and if we calculate the standard deviation by applying the formula 2000 by 5 divided by, that is the square root of 2000 divided by 5. So you will get the answer 20. So coefficient of variation will be 20 divided by 60 into 100, 33.33. So with this, problem is not over, dear students. I know the steps are clear. You would have understood in a better way. You need to write a conclusion. So you need to compare the results of both batsman A and batsman B, and you need to write batsman A is better because the coefficient of variation is less, whereas batsman B variation is more. Clear? So I hope this problem is very clear to understand the variability, and which variability is very less we select. So that is the objective of calculating standard deviation. So I hope this problem is clear to understand. So let us see problem number 2, an analysis of the monthly wages paid to workers in two firms A and B belonging to the same industry gives the following results. So this is the problem. Firm A and B, number of wage earners, monthly wage, variance is also given. What we need to calculate, step 1, find which firm pays out the larger amount as monthly wages. Step number 2, in which firm is there greater variability in individual wage. So how to calculate? Let us find out the steps to calculate one by one. So we need to calculate for firm A and firm B. What we need to calculate? Step number 1, we need to calculate the total wage. How to calculate? Average monthly wage multiplied by number of wage earners. It's already given in the question. 52.5 for firm A multiplied by 586, you will get 30,765. Same way, if you calculate for firm B, 47.5 into 648 will give you 30,780. So we know the total wage for firm A and firm B. Now, factory B pays out more wages than factory A. So if you compare this two, which is paying more? Factory B. So we need to write the comments like this. Factory B pays out more wage than factory A. Now the next step, solution number 2, we need to find standard deviation for variance. We need to find the variance. Here, square root of 100, if you calculate, it is 10. So coefficient of variation 10 divided by 52.5, if you multiply by 100, you will get 19.05, right? Standard deviation divided by mean already it is given, that is nothing but your average monthly wage. So 10 how we are getting is the square root of 100, already it is given there in the problem. Then the same way we need to calculate step 3, that is for firm B. So if we find out the variance, it is 121. So 121, if you calculate the square root, it will be 11. So 11 divided by 47.5. What is this 47.5? Is the average monthly wage of firm B. So if you multiply by 100, it is 23.16%. So which is having more variability? Factory B has greater variability. They are asking very clearly. Here you should not write a comment which is having less variability. They are asking a comment which factory has a greater variability. So factory B has greater variability than factory A. So this is what you need to understand with regards to calculation of standard deviation. So let me roll back and find out in the question. As you can see, variance of distribution, can you see here, dear students, the variance here 100 and 100 and already given in the problem. That is why I'm taking directly like this. See here. So this is how we know how to calculate total wage and write the comment. See, this is the 100 from the question. Already it is given. What we are doing, we are simply find out these variance by using the square root, right? As well as for firm B also we do the same, and finally we identify firm B has greater variability than firm A. So factory B has greater variability than factory A. So this is the comment finally we need to write with regards to this problem. So I hope this example is clear. So let me test with some multiple choice questions. For example, which of the following show light on the formation of the series or distribution? Measures of central tendency, measures of dispersion, measures of location. Can you guess, dear students, what is the answer? Yes? The answer is measures of dispersion. Okay, let us see question number 2. When we have to select between any two series and the variation is given, which series is chosen, the one which variation is lesser or the one which variation is more? We have done two problem. Okay, we have to select between any two series, variation is given. And which series you have to choose, which is less or more? Which is less or more? Can you guess, dear students? Yes, the answer is variation is less. If they say only choose greater variability, you need to choose greater. If they don't say anything, you have to choose which is lesser. So these are the vital points you have to keep it in mind. So this is the reference link I have stated. So for further reading, clarification, you may go to the ProQuest website and understand. So dear students, with regards to chapter 3 on dispersion, it is over. So if you have any questions or doubts, you can contact your respective managerial statistics course lecturer and you can clarify your doubts. Thank you very much.